Okay, so problem number 11 is saying that the waiting time in minutes at a bus stop follows a uniform distribution. So uniform distribution, and the range is given from 0 to 10. What is the probability that the total waiting time over 30 occasions exceeds 150? So uh, how can we solve this problem? Any idea? So there are certain given things that uh, waiting time, let's say there are multiple waiting times x1 x2 up to x30 events, but each of the xi is following uniform distribution, uniform over the interval 0 to 10. Okay, so each x is having the distribution of uniform probability distributions. So we are being asked what is the probability that the total waiting time over 30 occasions exceeds 150 minutes. Now we can define a random variable x as the sum of all these xi's. I varies from 1 to 30. So it's asking that what is the probability that my x, the total waiting time exceeds 150 minutes. So can we calculate this probability? How can we calculate it? Yes.
So we need to find out the p um, time is greater than 150, and then the uniform distribution of that uh, between 150 to um,
Mm-hmm.
first between 115 to the total interval of the
So okay, if I so each xi is following uniform 0 comma 10. So what is the expected value of each xi? Uh, you know that
0,
if you have uniform a comma b, then its expected value is a plus b by 2. That is a midpoint, right? So uniform means the distribution is like this, constant height, right? In this case, the
right.
probability, or all the times where probability are calculating for the continuous case, we are evaluating the area. Some particular point, we have point a and b, and the expected value is the midpoint a plus b by 2. Okay, so what is the expected value of x? Now x is sum of all these xi's, right? So this will be expected value of summation of xi's. I varies from 1 to 30. So this will be sum from 1 to 30 expected value of each xi. Why we are doing this? Because expectation is following the linear property, right? So this will be each variable xi, the expected value is expected value of xi is as I have written that it's a plus b divided by 2. Now a and b are given at 0 and 10. So this will be 10 divided by 2, which is 5, right? So expected value of my x, final total waiting time x, is what will be that? This will be 30, because we are 30, it's same 30 times, right? 30 times 5, this is 150, right? So this is my expected value of total time, but still we have not solved the problem. We have to find this probability we have to find. So actually whenever you are using the sum concept, you try to recall that whenever there is some kind of random variables, we can use central limit theorem. So what is central limit theorem? Anyone? So if we have a set of random variables x1 up to xn, and these are all IID means identical, they are following the same distribution and they are independent, then what? X bar minus mu divided by sigma by root n, this will follow what? Normal 0 comma 1. That's the uh, concept of central limit theorem. Yeah, am I getting some message? Or so you know the statement of central limit theorem, right? central limit theorem. This helps us to go from any distribution to the normal distribution, but this is when you are doing kind of sum. So this x can be written as the, so how can we write this x? If I'm taking average of all xi's, average of all xi's from 30, this will be, let's say I am denoting this by x bar. Okay, so my x can be written as, and my x is sum, right? Then my x can be written as 30 times x bar, right? Can we write this?
Yes, sir.
Let me admit. Yes, we can write this, right? So my problem of probability that x greater or equal to 150 can be written as probability that 30 times x bar, right? 30 times x bar is greater or equal to 150. So if we try to use the central limit theorem, as I have already calculated the expected value of this.
But how this x bar came, can you just explain again?
How this x bar came? See, our x is total waiting time, and it is a sum of 30 various variables, right? Then I can write the average of these 30 variables as summation xi I varies from 1 to 30 divided by 30. This is the average, right?
Yeah, I got it.
Right. So my x is 30 times x bar. So originally we had the problem that we have to find the total waiting time is exceeding 150 minutes. So we can write it this way. Now if I use my central limit theorem, my expected value of x, I got 150. Okay, so x minus expected value of x divided by variance or the standard deviation of x should follow normal distribution, and x is in the form of sum, right? So this concept from the central limit theorem I am using. So this will be, what will be this? 30 times x bar minus 150 is greater or equal to 150 minus 150. So this probability that this, if I divide by the standard deviation, which I have not found, but still I can denote that with SD, standard deviation of x. So for before that we have to find variance of x, and in case of the uniform distribution a comma b, then we know that the expected value is as let's say this is my variable y. Expected value of y is a plus b by 2, that I already told you. We can also find the variance of y, which is b minus a whole square by 12. This is the variance of the uniform random variable in the range of a to b. Now from here you can calculate the standard deviation, but you know that your actual x variable is a sum of xi's, so you can calculate the variance from that. If you divide that variance here, and let's say we denote that with the SD, standard deviation we are using, then this whole thing will be converted to a random random variable. Okay, this will be a normally distributed normal standard normal 0 comma 1. So what is the probability that z standard normal is greater or equal to 0? So you know that the standard normal is having the shape like this, and this is origin, and this area beyond origin is 50%, and this area is 50%. Total area is 1. So what will be this area now? What will be this area probability? What will be this probability? So it will be half, it is 50%. Is it clear what we did in this case? Am I audible?
Yes, sir.
Yes, sir.
Okay, so the concept of central limit theorem is being used in this case. Let's see another part of this question. It's not working. So another part of this question says that the and this is something different. It's not, it is a part of question 11, but it's not related to question first part first. So the distribution of a certain quality characteristics is continuous uniform over -8 to 4. And if M is the arithmetic mean of quality characteristics for 48 randomly chosen items, then find the probability that 4 times M is less than -9. So let me insert some space here more. So part B of the question 11 is saying that your xi is now following uniform -8 to 4. So what will be the expected value now in this case of each xi? This will be 4 minus 8 divided by 2, which is -4 by 2, which is -2. This will be expected value of xi. Now your M is arithmetic mean, which means you are summing your xi's. I varies from 1 to 48, and you are dividing with the 48. So M is your arithmetic mean of these xi's, and we have to find probability that 4m is less than -9. Again, we will use the concept of central limit theorem. So probability that M is less than -9 by 4. Okay, this is same. Now if my expected value of each xi is -2, what will be the expected value of M? Expected value of M. Yes. What will be the expected value of M? So this will be expected value of this summation of xi's. I varies from 1 to 48, and you are also having in the denominator 48. Taking the 1 by 48 common out of the expectation, now this will be sum of xi's. This will be, and as the expectation is linear, so 1 by 48 times summation I varies from 1 to 48, expected value of xi, right? So this will be 1 by 48 summation. Each expected value is -2, and you are doing from 1 to 48 times, and you are also dividing with 48 times, so this will be -2. So expected value of M is -2. Is it clear till now? So what we have to find the probability that M is less than -9 by 4. So what you do, probability that M minus expected value of M, and if you divide by the standard deviation of M, this should be less than -9 by 4 minus expected value of M whole divided by standard deviation of M. Standard deviation we have not found yet. So let's first calculate the variance of M. Yes, anyone wants to say something?
Sir, how this 48 came into the picture?
Yes, can you repeat?
How this, is it 41 by 48 is like, or 1 by 40?
1 by 48. 1 by 48. Random variables here. Let's read the question again. It's saying that the distribution of a certain quality characteristic is a continuous random uniform, and M is the arithmetic mean of the quality characteristics of for 48 randomly chosen items. Then we have to find this probability. 4M is less than
Got it, sir.
-9.
Thanks.
Yeah, your
Sir,
voice is
can you
breaking.
just, uh, yes. Can you hear me now?
Yes, sir. 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 Yes,
Hello.
Yes, can you please repeat what you are saying?
So what is written over here? Like P probability of M minus expected M expectation or upon what is in
Yeah.
the below?
What is
That below side what is written?
this is to m minus expected value of m divided by standard deviation. This is we are trying to write in the terms of the like central limit theorem formula.
Okay, okay.
So you know that central limit theorem is x bar minus mu divided by sigma by root n kind of thing, right? This follows normal. So x bar is our m arithmetic mean in this case, and mu is the, if we have n number of random variables which are IID, and each is having mean mu and variance or standard deviation sigma, then these two, knowing these two parameters, you can define this random variable, and its distribution will be always a normal distribution. Okay, so variance of m we have to first calculate variance of m. This will be variance of 1 by 48 times summation of xi, I varies from 1 to 48. So what about the variance? Is it linear or is it it's not linear? What do we know about it? Yes. So this will be 1 by 48 square. Square will come out, and this will be summation I varies from 1 to 48 variance of each xi. You know that this property of the variance, like how can we take constants out? Their square will come out, and if they are uh, you know this property of the variance. Okay, so but what about the variance of xi, each xi?
No, sir. How this came, like the square thing?
Oh, it's not clear. Okay, let's say we have a variable z which is ax plus by. Okay, now if these x and y are independent, if they are independent, then variance of z is actually equal to variance of ax plus by, and this will then in this case a square will come out, variance of x plus b square will come out, variance of y. If we have some constant c here, then its variance is 0, so that will lead to 0. 0 will come out in that case. So this is how we are using the property of variance. So actually, what is variance? Variance is the second order moment. It is expected value of x minus mu whole square. Mu is itself the expected value of x. So this is, or you can also write it expected value of x square minus expected value of x in a simplification form, whole square. So this tells the variation about mean. So this is the second order moment. So variance of each xi can be calculated because this is a random variable, uniform random variable, and we know the mean and variance of uniform random variable. It's, so we know the variance of uniform. I already write here that if we have a uniform random variable, what is its expected value and what's its variance? Okay, but in this case we are having m of each xi is a uniform random variable. Now in this case this will be 1 by 48. Now each xi is having the same variance, so 48 variances will become here, and the 48 square is in the denominator. This will be variance of some xi, and xi is following uniform. So uniform distribution from -8 to 4. So this is your a, this is your b, and the variance is b minus a square by 12, and this will be 4 minus -8 its square divided by 12. This will be 12 square by 12, which is 12. Okay, so variance of m is also known. variance of variance of variance of m is, now here in the case of variance of xi we are substituting 12, so this will be 12 divided by 48. This will be, what will be this? 1 by 4, right? So now this and it's what will be the standard deviation then? Standard deviation of m, it will be square root of 1 by 4, which is 1 by 2. So coming to the original part of the problem, now this will be m minus expected value of m divided by standard deviation of m. Now this part should be a standard normal. Now this will be minus 9 by 4 minus, what is the expected value we calculated? It was minus 2. It was minus 2, right? Minus 2, and you are dividing with 1 by 2. Now this whole this part is a z variable, standard normal, and you are calculating z less than, and you simplify this part, it will come out to be minus 0.5. So this you have to calculate, probability of z less than minus 0.5. So from the standard normal table, this is your, this is your, let's say, normal. Now you have to calculate this area. Let's say this is minus 0.5 and the area below that point. Is it clear? Part B? Or you need some other?
What is the value you have put for SDM
What is the?
in the last after root by 4?
Yeah, then we are calculating the standard deviation.
No, what is it that last year? This one. What is this?
1 by, this is 1 by 2, yeah.
Okay.
Square root of 1 by 4 is 1 by 2. Okay, that we are using here, and this part is coming from the central limit theorem. Central CLT, you can say, central limit theorem, CLT. Okay. There is also part C of question number 11.
Sir,
And
in
there
the
are,
part, sir, in the question number 2, the last part. Just,
yes.
So when we solve this like minus 9 by 4, so is that coming minus 0.5?
Yeah, it should come. What was it coming out? If I have done some mistake, you can point out what's it.
So is it that solution for that whatever we written in the top, like this part? Like from where this minus 0.5 came actually?
Minus 0.5 comes, you should simplify this part. This part, minus 9 by 4 and minus times this, minus 9 by 4 minus expected value of m divided by standard deviation. Let me zoom it in. Yeah, it should come minus 0.5. And this part is your standard normal. And we are claiming that this follows normal distribution because of central limit theorem.
So after this also we have to calculate that area, right? Like for z less.
Yeah, exactly. Then you have to use the standard normal table. Standard normal table is actually there are tabulated points, and
Yeah.
those points are giving you the areas. If you want areas and those points, if there's a point, what is the area below that or above that? That will be a particular table will be telling you whether it's calculating area below or above. If you know below area, then you also know above area, because its total area is 1, and if this is, let's say, alpha, this will be 1 minus alpha, right? So sometimes they give upper side of the tail, or sometimes they give lower side of the tail, or sometimes they give this part.
So for this we have to follow the tail, some tail probability distribution.
Yeah, you have to look at the probability table, actually normal table, and that will be given to you always when you go for that exam. Okay, because this is kind of, you are finding area under a curve, and it's numerical technique. Numerically, these areas are already calculated numerically, and for some specific values, some common known values which are mostly used, those will be supplied to you in the exam or anywhere you are using those values. or you may have written some program that is calculating this area with any of the techniques, known techniques. If you have heard of Simpson's rule of integration, or Simpson's 1/3, trapezoidal rule, all those rules you can use. But in the case of this course, you will always be supplied a probability distribution table for the normal case, or also for some chi-square distribution. Clear?
Yes, sir.
Okay, let's move to the another part of this problem 11. So problem 11 part C is saying that the distribution of a scores in a public examination is to be known to be normal. It's known to be normal with a mean mu and standard deviation sigma. We don't know this mean mu and sigma. It's providing us some other information that 20% of the candidates score over 80, 30% of the candidates score below 40. Find the ratio of mu by sigma, which means we have to first calculate mu and sigma, then take its ratio. Second part says that if mu and sigma are given, then find the probability that among 100. Second part is a bit different than the first part. Let's first solve the first part of part C. So part C, first part. Okay, so distribution of scores is distribution of scores in some examination is known to be normal. It's known to be normal with the parameters mu comma sigma. Right now we don't know this mu and sigma, but it's giving us the information that 20% of candidates, those candidates score over 80. Their marks are greater than 80, and 30% candidates score below 40. Okay, now if you graphically look at the distribution, normal distribution, this is your bell-shaped curve. Now it's saying that let's say this is my point, this is 80 marks, and this is 40 marks. Now this area is, which means candidates, this is 20%, which means 0.2. This area is 0.2, and candidates scoring below 40, which means the proportion, their proportion is 30%, a bit bigger than this. We can say, let's say this is 40. So below 40 is 0.3. So this is 0.3, 0.2, which means 0.5 total. In between area is, this area will be 0.5 because total area is 1. Yes? You want to say something? Okay, so this is the information given, and we have to find the ratio of mu over sigma. The parameters of the distribution are not known. From this condition, we have to calculate those. So you know that what is the density function of a normal distribution? 1 by root 2 pi sigma e to the power minus 1 by 2 x minus mu by sigma whole square. So this is the density function, right? And which means this heights at each points can be calculated. This is actually what this function is representing, and we are interested in the area under that function. Okay, now we are given that probability that x greater than equal to 80. This is 0.2. We are given this condition is given here, and also it's given that, so what will be this if this is 20%? How can you calculate? What can you do here? We can write it in this form: x minus mu divided by sigma greater or equal to 80 minus mu divided by sigma. So I am doing transformation on both the parts of the inequality. The system will remain invariant. What we are doing here actually? Normal random variable is converted to standard normal. It's taking time. Yeah, so what we are doing here, so this part now will be a standard normal z. So if we have a random variable x with the normal with the distribution mu comma sigma square, then x minus mu divided by sigma, this will follow a standard normal 0 comma 1, and the values of all the values at particular points for this standard normal are known. So probability that my z, this will be a z variable, z is greater or equal to 80 minus mu divided by sigma, and this is 0.2. So if you look at the normal table again and you try to find a value uh, z naught, point z naught, beyond which the area is 0.20, so let's call that point z0, then the probability z greater or equal to z0 is 0.2. Now this z0 you can get from the normal table, and if you compute, I have already calculated the value of this z0. So my z0, which is actually coming out to be 0.8416, and I am equating this with 80 minus mu divided by sigma is equal to 0.8416. Okay, now from here you are getting equation of mu and sigma. 80 minus mu is sigma times 0.8416. So this is one of the equations we got. Now another equation we can get from this is probability that the proportion of candidates whose marks are less than 40 is 0.3. This is also the given information. So using the same standardization technique, x minus mu divided by sigma, this will be less or equal to 40 minus mu divided by sigma, and this is 0.3. So probability that z less than z naught is 0.3. Now you are looking at some another point, let's say z1, we call this z1, point z1, beyond which, below which the area is 0.3. So from the normal table you can get this value as the value of z1 is minus 0.5244, 5244. This I have calculated. So now equating this to 40 minus mu over sigma equal to minus 0.5244. Now you get some another equation between of mu and sigma. You got a system of linear equations with two variables, two system of linear equations. Solving these simultaneously, you will get the value of mu and sigma. And if you get the value of the mu and sigma, your final answer for mu will be and sigma will be this. This you can calculate by yourself. Okay, this is your mu and sigma, and you have to take the ratio mu over sigma. Is it clear what we did in this part? Any query in this part? What we did? Part C of the question number 11. In the first part of that.
No,
Yes?
sir. Sir, hello.
Mm-hmm.
Yeah, sir, can you help us to how to look into the Z table for these reverse values? Can you show us
How to look the normal table values?
the Z table values
Uh,
reverse form?
I think that will be discussed in the class, but still, uh, then I have to go for, okay, let me show you normal table. If you look any of the tables in the online, okay, let me share that part also, screen. So here you will get normal table of this type, this kind of thing you will get, and each table will be having kind of diagram above that table, which is showing what kind of values it's calculating. Yeah. So this is your normal table. Okay. So on the columns there are probability values. Okay, probability rows and columns, like let me, there are, can I edit this, can I write on this? Yeah, so on this, it's not clearly, wait, yeah, can you see this normal table right now?
Yes, sir.
Okay, so for each value, these are z values. These are z values. Here it is like say z, and there's a precision for that, for how many decimal places you are looking for. Let's say this is 0.001, and the value you are getting are the probability values in between. So let's say for a value of, I am having the value of z as, the first entry of this table is 0 point, what is that? Yeah, so 0 comma 0 is there, and 0 comma 0 is there, 0 comma 1 is there. This is showing the precision value of z you are having. Now the entry value is 0.5. What is the meaning of this point? And the graph you have to look at. Your graph is like this. Your graph is like this, and it's showing the area below that point. So if my z0 is point, z0 is 0, 0 is, this is my point. Okay, if my point is 0 comma 0, which means 0.00 is my point, then the area below that point is 50%, which is what is written here. If you can see this table, that is what is written in here, the first entry. So now you can go in the reverse way. If you know this, if you know the area, 0.5 is my area, what will be that point, z0 point? You can go in both the ways. Did you get it, what I am saying?
Yes, yes.
Okay, so this is how you calculate the normal table. Let's go back to our,
So, sir, in
yes.
that question, the previous question that we had,
Mm-hmm.
if I look into the table, I have to search for 0 0.8 for the first part where the 0.2 is coming. I have to search for
Yeah,
0.
you have to look at the point which is giving you this 0.2. Now you will look the in table, you will look the point 0.2. Let's say that point is here, 0.2 in the table. Okay, the probability value. Now you will look that value under that row, the entry, heading entry of that row. Okay, and let's say this is one, what was this point coming out to be? 0.8, right? 0.8, let's say this is 0.8, and there is a precision, like we are going for 2 decimal place, 3 decimal, and it will be showing 0.80, 0.81, 0.82, 0.83, 0.84, and we are looking for 0.84, right? So it will be the probably 2 point something like that. So this is about the precision. So you have to go in the reverse way. Now the probability is given, what is that point, z point, and you have to be careful about the graph of this, how the normal distribution table is given. In this case, it was given that the area below that point, it may be given that area above that point. Okay, that you have to be careful. Then you have to flip the points, and it may also be given that the tail probabilities are given, the tail probability beyond that point. So looking at the graph of that, you have to accordingly select how you can adjust the values. Okay,
Oh, good.
so another part of the problem is, second, I think you should you try this, the remaining part of this question number 11. Otherwise, it will take whole class for this only 11 problem. Then let's move to the next problem. Okay, so which problem is next? Problem number 13. 12 is already discussed in the class. Let's go for problem number 13. Let's try to first understand what's given in the problem. So our problem is saying that there are two machines A and B in a factory. The number of defectives, say X, produced by defect number of defectives, say X, produced by machine A on a particular day follows the Poisson distribution with mean 2. Also, the number of defectives, say Y, produced by the machine B on the same day is equal to 0, 1, 2, or 3 with the probability of 0.25 each, and the independence of two machines can be assumed. Now it's asking us, given that exactly two defective items were produced on that day, find the conditional probability that one of these defective items came from machine A and other came from machine B. Let's go by step for this. So question number 13 is saying that we have two machines, machine A and machine B, and there are some defective items coming from this, defective items coming from this. If we count X as the number of defective items coming from A and Y as the defective items coming from B for a particular day, and it's given that this X is following Poisson distribution, Poisson with the parameter 2. What is this Poisson distribution? You know, and y is counting the defectives coming from B, and it's taking the value 1, 2, 0, 1, 2, and 3. Each is having the probability of 0.25, 0.25, and so on. Four possible values and their probabilities. So this is the probability mass for Y. So what about the probability mass of X? If I have, let's say K, X is taking a value K from the Poisson process, you know that if we have the parameter lambda to the power k, e power minus lambda to the power k factorial. This is how you calculate the probability mass value at a particular point k. Now we are given that lambda is 2 here. Lambda is 2. So probability that X is any value k, this will be 2 to the power k e power minus 2 divided by k factorial. Okay, so this is about the Poisson process. So what else you know about the Poisson process? Its expected value is same as its variance. This is the property of the Poisson process, and in both are lambda, which is in this case is 2. And why you already know that y is taking these values 0, 1, 2, and 3. They all are having the probability of 1 by 4 or 0.25. 1 by 4, 1 by 4, 1 by 4. Okay. Now this is the given information, and A or B are producing the event. A and B, it's also given that they are independence of two machines can be assumed. Okay, they are producing independently. Now the first part is saying that given that two defective items, now there will be defective items coming from A, which the value is X, and there will be defective items coming from B, and the value is taken by the random variable Y, and this total value is 2. This is given. We have to find the probability that X is equal to 1, Y is equal to 1, given that X plus Y is 2. This is the conditional probability we have to find. Given that two defective items were total obtained on that day, and you have to find the conditional probability each each machine produced one defective item at that time. Okay, is it clear? Question till now? So this, you know that probability, conditional probability, this can be calculated.
Can you just explain the last sentence again?
Yeah. So we have two random variables. We have two machines. I'm again saying that the random variables X and Y are counting the number of defective items coming from those machines. X is following some distribution, Y is following some distribution. This is Poisson process. This is some discrete process. We don't know what its name. Now we are given that there are two defective items obtained, defective items obtained on a single day. On a particular day, two defective items were obtained. Now these defective items will be coming from A, which is counted by X, and these will be coming from B, which is counted by Y. The aggregate value of the defective items, there are, that means total there were 2 defective items obtained. So no, so this may be coming from X, this may be coming from Y. So their sum is the total number of defective items, right? Now it's asking us, given that we have total 2 defective items obtained on a particular day, what is the probability, conditional probability, that each machine produces 1 defective item, which means 1 coming from A, 1 coming from B. Together they are contributing the 2 defective items. Okay, clear?
Yes, sir. Yeah.
Now this is the conditional probability. So probability X, this is how we calculate the conditional probability. You can calculate this. Can you calculate this? So if I go for probability that X plus Y is 2, total 2 defective items were coming, this will be, we don't know, like one may two of the defective items may be coming from one, and 0 defective item may be coming from another, right? That may be the case, that X is 2, Y is 0. This is one of the case. Plus probability that X is 1, Y is 1, plus probability that X is 0, Y are 2. So these are all possible cases. This is, we are using the total probability law kind of thing here. Okay, now what about this probability X is equal to 2, Y equal to 0? How can you calculate this probability? This can be written as probability that X is equal to 2 times probability that Y is equal to 0. Why we are using this? Why we can do this? Any idea here? Similarly for here, this can be written as probability that,
Because
yes,
both occurrence are independent. That's why.
yeah, that is the condition of independence. So their intersection, the joint probability, that will be the product of their probabilities. Or also in the case of continuous, the distribution, the density function can be obtained as a product of the marginals. Okay, so that's the way we are using the condition of independence here. Now probability that X is equal to 2, since X is coming from Poisson process, it will be, what will be this? 2 to the power 2 was our lambda, right? 2 to the power 2 e to the power minus 2 divided by 2 factorial. This is coming from Poisson process, as I write here, how you can obtain probability of particular value of X given. This is from the Poisson process. Okay, lambda is 2 given there, and you have to multiply here probability Y is equal to 0. So Y is taking value 0, 1 and 2, 0, 1, 2 and 3, and each is having the value probability of 1 by 4 or 0.25. So we can use that here, right? So 1 by 4 will be here, or 0.2, and similarly you can calculate the values for these cases, and if you sum all these values, you will get your total value to be probability that X plus Y is 2. This value you will get, I will write only the total aggregate value of these things. Okay, let me write the individual first, it will be clear. 0.25 minus plus 0.25 minus, and this is 1.25 e to the power minus 2. So this is your probability of X and Y are, X plus Y is 2. Now you have to calculate the other part also. What's that? That you have already calculated actually. You have to put the values here, and you calculate the X is equal to 1, Y is equal to 1. That you calculate with the product of the probabilities. Okay, and this value was coming out to be, what was this value? It was 0.5 e to the power minus 2. Take the ratio of this with this value. Take the ratio, you will get your total probability 0.4. Is it clear what we did here? So we write the conditional probability in terms of its definition, and we with the total probability law, we obtain the values of these individual elements and using the independence criteria, and we already calculated the numerator part in this case, and whole ratio is your total what you were looking for.
Sir, why this probability of y is equal to 0 comes as, is it 2 by 4 or 1 by 4?
1 by 4, 1 by 4.
Okay.
Why is having that probability mass function that's already given? It's 0.25, which means 1 by 4, 1 by 4, 1 by 4 for all the cases.
Yes, yes.
So let's go for another part of this question number 13. Let me see. Yeah, question number 13 has other part also. Or shall I leave this another part so that you can give it a try, and we will move to some other question. Can I leave it as an exercise for you guys? Okay, question number 13 part B, you try, and if you are not able to solve it, then I will solve it in the next class. Okay, because I want to touch other questions because we have very less time. Shall we go for another question? Am I audible?
Yes, sir.
Okay, so then I'm going for question number 14 because we have to solve other questions also. That's why. So question number 14 is saying that the length of life in years of a certain type of automatic washer is normally distributed with a mean and standard deviation given. If this type of washer is guaranteed for 2 years, what fraction of original sales will require replacement? Also calculate the probability that out of total 240 such machines, at least 115 will require replacements as a consequence of guarantee. So let's see what is given. Now let me see where I have solved this question. Quickly we will do it. Yeah. It's saying that the length of life of a certain type of automatic washer. Okay, that let's say washer that's following the distribution normal mu with 3.1 and standard deviation 1.2 square will be the variance. Okay, this is how we write the normal mu comma sigma square. Now things are guaranteed. There is a guarantee for 2 years. 2 years for these automatic washers. Now some of those washers may not work for 2 years. They will fail before 2 years. Then they need replacements. Okay. Now we have to calculate what fraction of the washers. The first part is saying what fraction of the original sales will require replacement. So W is following normal mu comma sigma square. Mu and sigma are known. We have to find probability that W is less than 2. So proportion of washers whose lifespan is less than 2 years, those will require the replacement, right? Now distribution of W is known. I will subtract its mean and divide by its standard deviation. This will be 2 minus 3.1 divided by 1.2, right? This will be probability that Z is less than minus 0.9167. This value I have calculated, proportion. Okay, 2 minus 3.1 divided by 1.5. Now this was a normal. Now if I am subtracting its mean and dividing by its standard deviation, this will follow the standard normal 0, 1. Okay. Now this value you can calculate from the normal table again. Now you are looking for a point. This point is given, that is minus 0.9167. You have to calculate this area below that. You can go to the normal table and look for the value for this particular value. What is the probability for given this value of Z? What is the probability? The area below the point, area below, like the area under the curve beyond like this point on the left side of this point when this value is given, and that value comes out to be this value. Probability comes out to be if I denote it as a p, it comes out to be 0.1796, almost 17.96%, which is almost 18%. So 18% of the fraction or 0.1, this amount of fraction requires the replacement. Okay, clear till this point? Now we are it's also saying that calculate the probability that out of the total of 240 such machines, at least 115 will require replacement as a consequence of guarantee. Now this problem is not the same, like there is not the same random variable we are using. Now we are having 240 such machines, okay, and there is a probability of 18% that a machine will fail below the 2%, below the lifespan of 2 years, and that is your probability of success probability. Now there are 240 machines, okay, 240 machines, and each machine may work for 2 years, more than 2 years, less than 2 years. That out of then now there is a kind of binary decision. It may work, yes, or it may not work, no. Now if it works, okay, if it's not working, then what kind of random variable we will have? Now we have binary kind of random variable, and we have to check out of 240 what is the probability that at least 140 out of 240 115 will require the replacement. So if I try to address this using another random variable, I define my random variable. It's taking time. Is it clear till now what we discussed, and what is the next part of the problem? At least problem should be clear. Now we have 240.
Can you please repeat, sir?
Okay, so see, we have the lifespan of the automatic washer as a normally distributed. That that the parameters of that thing were already given, and we were asked what is the proportion of the original cells for which we need a replacement, which means there is a guarantee that if your product is not working beyond 2 years, then we will replace your product. Then we calculate the proportion of the sales for which there was a requirement of the replacement, because they were items were working less than the 2 years of their expectancy, life expectancy. So we calculate that area, that proportion is 18%. Okay, so this is the proportion that if whatever your sale was, this is the proportion for which there is a requirement of the replacement. Now 240 such machines were selected. Okay, it's asking us at least what is the probability that at least 115 will require replacement, which means 115 will fail below the 2 years of their life. So now we have 250 machines. Now each machine may work or may not work. There are only two possibilities. Okay, now if I define my new random variable y as number of machines, number of washers that fail within 2 years. Now these many number of machines will require the replacement. Why is that number? We are given that 240 are selected. What is the probability that 115 will fail? But before that, we have to calculate this. We have to identify what will be the distribution of my y. What will be the distribution of this? Anyone? So it will be a binomial distribution. Now we are having n number of n as 240. This many number of machines. It's now type of coin tossing among these, and we have to calculate particular proportion will fail. or particular kind of heads or tails will occur. So this is binomial n is 240, and the proportion that the machine will fail is the success probability, we call that p, which is 0.1796. Is it clear why this is following the binomial distribution?
So it will come at 0.1796 or 0.9167.
0.1796, almost 18%. This is your now success probability for the case of binomial. Earlier, this was the proportion of the original sales for which we need the replacements. Now we are given that there are 240 total such items. Let's say for these items, if I ask k number of replacements will be required. So that you can, the way I have defined it as a binomial random variable. So what I was saying, it should be clear why we are using the binomial distribution here. Why we are using the binomial distribution, and why we are taking the specific parameters. Okay, now if y is that random variable which is counting the number of washers which fail within 2 years, so we are asking that probability y is greater or equal to 115. At least 115 items will fail within 2 years. So how do you calculate the probability of a particular event in case of binomial distribution? Probability that y is k will be n choose k, p to the power k, 1 minus p to the power n minus k. This thing you know that? This thing you know in case of binomial, this is the probability mass function of binomial distribution, right?
Yes, sir.
And what is the expected value of y will be? It's a binomial random variable. If we have the binomial n comma p, then its expected value will be np, that you might have calculated, and its variance of y will be np into 1 minus p. So this is the generalization of Bernoulli trials. We have the expected value p into 1 minus p as the variance, and when we have n such events, independent events, then it becomes binomial distribution, and the expected value is np. These values you should know. I mean, when you study the distribution, you should know what are the particular parameters of that distribution. So I can use this probability y minus expected value of y divided by standard deviation of y. This should be greater or equal to 115 minus expected value of y divided by standard deviation of y. So again, from the case, this will be z greater or equal to 115 minus expected value, which is n into p. N into p, in this case n is 240, probability is 0.1796. This value is coming out to be 43.104, and the variance is coming out to be standard deviation, which is square root of the variance. If I substitute the values, I will directly write the value 5.94. Now put these values here. Now this will be 43.104 divided by 5.94. Now this is our standard z. Here is something you need to take care. Anyone can identify what's missing here? If you know what we are using here, we are actually trying to estimate a discrete distribution by a continuous distribution. Binomial distribution is a discrete case, right? And we are approximating that with a standard normal. What will go wrong here if we are not careful? Can we go this way, or do we need to make some adjustments?
Central theorem possibly we need to convert.
Yeah, central limit theorem says about the IID sequences. We are, I did not state that we are using IIDs. Actually, there is a concept of uh, correction factor here. Oh, it's not this. Let's wait for a minute. It's so there's a concept of correction factor. If yeah, so correction factor. See, your binomial distribution is having particular values, heights at particular points, and its shape is kind of normal, looking like shape. The actual normal is like this, right? So you at a discrete point you are approximating the probability with the normal table, with the normal distribution. Then you need to add a correction factor, so that may be epsilon, z plus epsilon or z minus epsilon. That's called the correction factor here, that you should take care when you are actually using. I did not say that I'm using central limit theorem. I'm saying that I'm standardizing it. Then from discrete to continuous case, what adjustment you should go. Then this correction factor is usually taken as 0.5, so I will be taking 0.5. So my original case y greater or equal to 115 is actually by the approximation of normal approximation y. Now this will be minus 0.5 greater or equal to 115 minus 0. Now your adjusted variable is this, and your mean is this. Okay, with this adjustment you should go for, then you should use the concept of central limit theorem. Okay, this in the case of binomial to continuous case, you should be careful. So if I write the answer for this case, our original problem, there was adjustment of 0.5 here, adjustment of 0.5 here. Okay, accordingly there will be changes, and the total value, if I write total value, your actual probability z value, z greater or equal to 12.02. this is, so what will be this value? Probability is that z greater or equal to 12.02. This value after adjustment comes out to be 12. Can anyone tell me what this value can be without actually looking at the table? If you understand a normal table, you should directly be able to tell what will be this. Anyone? No idea. Am I connected?
Yes, sir.
Okay, so what can be the value of this? So if you have understood the normal distribution, with a good understanding of the normal distribution, this is your normal distribution. If this is your mean mu, which in this case is 0, then you know that within the one standard deviation, 68% of your data lies here. Within the two standard deviations, 95% of the data lies here. And within three standard deviations, almost 99.99% of your data lies here. So beyond 3 value, probability that z greater or equal to 3, this value is actually 0, which means the area beyond this value 3, if this is a standard normal, this value is 0. That's why we got value probability z greater or equal to 12. So if you get this high value for the standard normal, you can directly write the value 0. So this is the rule of observation in case of the normal. Your 68% of data lies within one standard deviations from left and right from the mean. If this mean is something different, then this will be mean plus mu plus sigma, mu minus sigma. This you should remember. Actually, this will be helpful in the case of hypothesis testing and other parts. In case of normal, these are very useful. So it is clear. Is it clear the question? What question was asking? And
So, sir, the final answer will be 0 here.
yeah, final answer will be 0, which means out of at least 115 machines will require replacement is probability of 0. Out of 240, it was saying what is the probability that at least 115 will fail, they will require replacement, with the condition that we were having 18% of the total failure possibility. So final answer will be 0. Okay, so shall we go for the next question? Question number 15 we should go. Yeah, let's do 2-3 questions more, and with that, I think you have quiz tomorrow, right?
Yes.
Yes.
Yes, sir.
Then you should like be very careful what we are solving here. But there's a high probability questions may be coming, or questions like this may be coming in your exam.
So, but the time is very less. Looks like 1.5 hours is not enough for that.
But that will be almost like for equal amount of time will be for all. So the per grading will be related to performance, will be judged accordingly. So if you are getting less time, everyone is getting less time.
Yes, sir.
Even if there are questions, lengthy questions, then depending on how much time you got and how much you are able to solve within that, I don't think there will be more than whatever is expected in 1 hour, 1.5 hour. That those many number of questions will be there. So
Yes, sir.
let's solve this question number 15 also, so that you get some idea and it may be helpful for you in your exam. So the question number 15 is saying that a factory manufacturer says two brands A and B, the distribution of life in hours of any bulb brand A is uniform over range 0 to 4. The corresponding distribution for brand B is uniform over 1 to 5. Four bulbs of which two are of brand A, 2 are of brand B, are put to a test in a live testing experiment. Let X be the number of bulbs that fail during the first 2 hours of the experiment, Y be the number of bulbs that fail during the first 3 hours of the experiment. Find the expected value of Y minus X and find the probability that Y is 3. So let us try to understand. There is a brand A kind of bulb, and the lifespan, like the distribution of life in hours of that kind of bulb is following the uniform 0 to 4. For any kind of bulb, for any bulb from brand A, the life will be of this distribution. For brand B, it's uniform 1, 5. Okay, so if it's uniform 1, 0, 4, what will be the density of this function? Now we are having total area is 1. What will be this height? So that total area is 1.
0.25.
0.26.
25.
25. 1 by 4, right? So 1 by 4. This is the, and for any point T, so probability that a bulb from A brand and its life expectancy will be till point T is probability. What will be this probability? This will be the area, right? Area till this point. So this will be T by 4, right? 0 less or equal to T less or equal to 1. This is the uniform distribution. This is the distribution of A, and for B, for the case of B, probability that B fails in T hours, which means life expectancy is less or equal to T. This will be, what will be this? Now we have 1 to 5. Total area is 1. What will be this height?
1 by 5.
This area, this is 4, and this should go 1 by 4, right? But what will be the distribution? Like if I have a point, what will be its probability of being here? This is my point T here. What will be this area? Now we have the width of T minus 1, and a height of 1 by 4. So this will be probability B of T. Okay. So for any kind of bulb from the brand B, the probability that its life expectancy is till point T is T. You substitute the value of T, and this is for 1 less or equal to T less or equal to 5. This is very important for what range of this, and 0, it's beyond this interval, it's 0. 0 here, 0 here. It's very important to know, like to write for what range of T, what is the value at distribution value at that point. Now,
Sir, in that, sir, in
yes.
that case, for P of A, it's the T should be between 0 to 4, right? Or 0 to 1 only.
No, this is for B, for brand
No,
B.
no, A, for A, I'm saying, like T will be.
Here, yeah. It should be 0 to 4. Yeah, thanks for pointing it out. This should be 0 to 4, 0 to 4, right? Now, what is the question saying? That X is counting the number of X is counting the number. There are total four bulbs selected. Total 4 bulbs are selected and they are put to the test. 2 are coming from A, 2 are coming from B. X is counting the number of bulbs that fail during the first 2 hours, and Y is counting the number of bulbs that fail in first 3 hours. Now we are given time for 2 hours and 3 hours. So for T is equal to 2. Okay. Now, what will be this probability that for probability that A fails in 2 hours, this will be, I will substitute the value T is equal to 2 in the distribution of that, in the distribution here, right? So this will be 2 by 4, which is 1 by 2. Probability that B fails in 2 hours. What is the distribution of B? This is our distribution, right? So this will be 2 minus 1 by 4, which is 1 by 4. These are the probabilities. Probability the failure of A kind of bulbs in 2 hours. Probability the failure of B kind of bulbs for 2 hours for each bulb. Now there are 2 such bulbs selected, and X is counting actually the number of failures in 2 hours. So let me write again this. X is counting the number of bulbs that fail in 2 hours, so it may be coming from A, it may be coming from B, but if it's failing in 2 hours, then X is counting that. So X, the distribution of X will be binomial 2 comma 1 by 2 plus binomial 2 comma 1 by 4. So this is the probability of success for that, which in this case is the failure. So probability of failure within 2 hours, and 2 bulbs are there. X is counting those. If it's coming from A, then this is the contribution. If it is coming from B, this is the contribution. Okay. Now it's asking us we have to calculate expected value of X minus Y. Before that, we will calculate expected value of X. What will be the expected value of X? This will be expected value from this part, expected value from this part, and this will be 1 by 2 NP. This will be 2 into 1 by 4 NP in this case, NP in this case, which is 1 plus 0.5, 1.5. And if we now Y is calculating, what's Y? Y is counting the failure of bulbs for time interval 3 hours. Now there will be probability A fails in 3 hours, A fails in 3 hours. This will be 3 by 4, because I will put directly the value of 3 here. if A is failing, okay. Now probability that B fails in 3 hours, this will be 3 minus 1 by 4, which is 2 by 4, 1 by 2, right? This is 1 by 2. Now you got the probability for each bulb, failure of each bulb, and again you are having the distribution of y to be binomial 2 comma 3 by 4 if it's coming from A, binomial 2 comma 1 by 2. Look at the expected value of y. This will be expected value of this plus expected value of this. This will be 2 into 3 by 4 plus 2 into 1 by 2, which in this case is 2.5. What is the expected value of x minus y? Y minus x. This can be written as expected value of y minus expected value of x due to the linearity property. And expected value of x and y we already calculated. With that you can find the value of expected value. Another part is showing the probability probability that y is exactly 3. So you should try this part. Okay. If any doubt still here, whatever we discussed, you can ask me, and rest of the parts you can try. You should also try some questions. To get some confidence, you should try questions. Okay. Any doubts till this point? I think the time is up, right? 9:30. 9:30. We have 30 only, right? So if